Hello everyone, this is Math 111Z, and we are looking at section 1.4 in our text today. So we have several videos that I'm just going to cover things with, and we'll just kind of go from there. So looking at section 1.4, this is rational expressions. Remember ratio? We talked about that last week. Ratio means rational expressions. Ratio means a fraction. So this is essentially a polynomial, p of x, over another polynomial, q of x. So if you take the fraction of two polynomials, you get a rational expression. All right, so there's so many ways that we can simplify this. Remember that, like here's one. This is just a constant over a constant. Remember, this reduces to 1/3. Right? You can think of this as 2 times 2 over 2 times 2 times 3. Those cancel, 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 and that's 1/3. You can also think of this as dividing out the greatest common factor, which again would be 1/3. Okay, similar idea is what we're going to do here. Let's say I'm looking at this. Most common mistake people make is like trying to cancel out something like this. You cannot do that. You cannot cancel it unless it's a product. And this is products. If it were, if I had written 2 plus 2 over 10 plus 2, and then cancel the 2, you would see that would be 2/10, which is the same as 1/5, which is not 1/3. So this is a fallacy. Do not do this. This is bad math. Bad math. Okay? So if I want to do this, though, I can factor this first one. We just practiced some factoring in the last chapter. We're going to use that a bunch. And let's see if I can factor this one. All right, so I need the 3x and 3x to become the 3x squared. I need a 4x in the middle. It needs to be negative, so I'm going to put a -1 there and -1 there, and then +1 at the end. Now, you'll notice a couple things, and a couple real important things. One, that x cannot be 1/3. Oh, please excuse me, I have a terrible cold. Just a little bit why these videos are late, because it just took me by storm yesterday. And x cannot be 1, because both of these things would make the bottom 0, and you cannot divide by 0, right? However, you'll see that I have a similar factor here and here, so I can cancel that out. Now, I don't really need to write this one, because anyone looking at this expression could see that x cannot be 1/3. But it's really important that I write this one. X cannot be 1. Because there's nothing in this expression that tells me that at 1, the original expression was undefined. So it's really important that we let our reader know that the original expression was undefined at 1. All right? So, all right. We can multiply and divide rational expressions. We can add and subtract rational expressions the same exact way that we multiply, divide, add, and subtract regular fractions. So if I have something like 3a times 24 over 8 over 6a cubed, and I can take an 8 out here and here. That gives me a 3. I can take a 3 out here and here. That gives me a 2. I can take one of these a's out. With one of these, and that will leave 3 over 2a squared. Now, look, these things have no common factors, and there's nothing else I could do there. All right. Likewise, if I have a trinomial and a trinomial, again, I'm going to have to factor and factor and factor and factor. All right. This is the difference of two squares. This guy right here won't factor at all. So, and this guy will factor. This is x plus 6 no, x plus 3 and x minus 2. Over here we have x plus 2, x plus 2. This guy is the difference of two squares, which is x plus 2, x minus 2. This guy does not factor, right? When you factor something, you're actually asking yourself when, like, in order to find a root, to factor, to find a root, this would have to cross the x-axis, and this never crosses the x-axis because you have something positive adding 9 to it, so it can't be. In math, we call that irreducible. So this would be x squared plus 9. All right, so cancel, 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 cancel. Now I need to tell the reader that x cannot be -2 and x cannot be 2. Otherwise, how will they know? X plus 3 simplifies to this, x plus 2 all over x squared plus 9, where x is not -2 or 2 in the domain. Okay? All right, so, and let's talk a little bit about adding and subtracting. Let's suppose I wanted to add this. Now, if I'm adding this, my first step is always going to be to see if I can take anything out that reduces. Doesn't look like this. This is going to be x plus 2, x plus 5. And it doesn't look like there's anything here that I can take out. I notice that I already have an x plus 2 in each of these. This one needs a 3. Right, so I'm going to put a 3 on the top and bottom. So essentially I'm not changing this at all because I'm multiplying it both top and bottom by 3 over 3, which is the same as multiplying it by 1. I also need an x plus 5 on the other side. So on the bottom, I'm going to have 3, x plus 2, x plus 5. On the top, I need to FOIL this out. This is going to be x squared plus 9x plus 20. FOILing these two out. Again, going a little slower here for you. X squared plus 4x plus 5x plus 20. And then plus 6x plus 3 from here. All right? And now we're going to add all these together. We get x squared plus 15x plus 23 all over 3 times x plus 2 plus x plus 5. I could check and see if this top factored, but it's not going to because 23 is a prime. So it can't be simplified any further. And 1 and 23 does not add to 15. All right, so. All right, and get a couple other ones. All right, simplifying complex fractions are a fraction over a fraction. Now, I find the easiest way to do this is just remember that if I had like 1/3 divided by 4/5, I would take the denominator, invert and multiply. A ridiculous old rhyme that says, mine is not to question why, simply invert and multiply, which ours is supposed to be questioning why, but there you have it. You have that. So we're going to do the same thing here. I'm going to have x squared minus 4 times, let's flip this up. And now if I want to simplify this, I'm going to factor this guy, factor my whole top, factor my whole bottom. That's going to be x plus 3x minus 2. This will cancel. x is not equal to 2. There you go. All right. I'm going to do example number 7. It's one of my kind of favorite when you have these guys. Because there's a trick you can do. I like to do. Right. If I look at all of these 4 things, what would the common denominator be? Y squared. That's the most y's. And x. Y squared x. So what if I multiplied the top and bottom of this by y squared x over y squared x? Right? Now, this would go into here. The x's would cancel. I'd be left with y squared. It would then go into here. 1y and 1x would cancel, and I'd have plus y on top. Right? Now I'd go into here. The y squared would cancel, and I'd have a plus 3x. And here, 1y would cancel, and I would have a yx. Right? And voila, that would be it. Right? There's nothing else I could do to simplify it further. I could take out a y just to make sure there's nothing else I could do to simplify it further, and an x. But truly, there's nothing else I can do to simplify that further. So that's kind of cool. I like that method. It's really nice. All right, so this is all your section 1.4. Thanks so much. Bye.